Hi, I'm Rich with insideHPC. We're here at SC17 in Denver, Colorado. And this afternoon, we are at the IBM booth with Ken King. Ken, I just want to get kind of situated here. How does IBM help with HPC, and what are you doing here at this show?
Oh, absolutely. We're an industry leader in HPC, and one of the ways we're demonstrating that is through what we're showing and announcing here. Well, not announcing, but what we're showcasing that we announced a couple years ago are supercomputers with the Coral, the Department of Energy labs, Oak Ridge and Lawrence Livermore. We're showcasing the fact that this is really our coming out party for Power9, Coral being the first instantiation of it, and the systems that we're delivering to both Oak Ridge and Lawrence Livermore. For example, the Summit system at Oak Ridge is going to be basically 200 petaflops, which is equivalent to about 200 quadrillion calculations per second, and over 2.5 terabytes of data throughput per second. These are going to be the fastest computers in the world. They're going to run all kinds of different workloads. And they are based on the innovative technology coming out with IBM and our partners through our open power collaborations.
So Ken, I want to double click on something you mentioned there, these innovations. Can you tell me more?
Yeah, absolutely. First, let me start with the processor. So this is our coming out party for Power9. We're going to have a lot more innovations and solutions and servers coming out as we roll out over the next number of months. But this is the first instantiation of it. Power9 is going to it has 2x the threads of x86, 2x the cache, over 50% more memory bandwidth, 5 to 6x the amount of I/O bandwidth with OpenCAPI, with our PCIe Gen 4. And a really neat feature in it is next generation NVLink. So this is we've got NVIDIA's GPUs, the Volta GPUs in it as well, which are the next generation GPUs. But the one thing we have in Power that you do not have with x86 is this next generation NVLink capability between GPU and CPU. Everybody's got it between GPUs, but between GPU and CPU, we've got NVLink next generation that's got over 150 gigabytes per second of throughput. So information super high between GPU and CPU, whereas PCIe Gen 3 is only 32 gigabytes per second. So significant enhancement between GPU and CPU to eliminate that bottleneck of processing data, whether it's for AI workloads, supercomputing workloads, HPC workloads, whatever that might be. So we are really excited about this capability and about our industry leadership here.
So Ken, you mentioned that this is coming around the corner in the near future. How does that compare to the schedule? How are you doing there?
Oh, we've got the first portion of this that are going to be available to the labs this year for them to start running all their algorithms and start testing that. And then the full thing will be delivered on the schedule that we have with the labs on schedule in 2018, which is unlike what one of the other competitors have done with their implementation. And I won't go into any more details than that.
Okay. Hey, I wanted to ask you about the number of nodes. Okay, so a lot of these machines of this scale, they have tens and thousands of nodes. You're doing this with a much smaller number of nodes. How do you pull that off?
Absolutely. Okay, an example of where we've done that, working closely with a partner named Stone Ridge Technologies, who provides capability around reservoir simulation. We work with a couple of clients in Stone Ridge in the energy industry, and literally took the calculations down from, they were running an Intel-based capability for this simulation using 700,000 nodes. And we were able to take that down to 60 processors and 120 GPUs to run actually slightly faster than that x86-based implementation. So basically taking it down from something the size of a football field, or this show, to the size of a ping pong table.
Okay, and I assume there's some real advantages there for the users when you've got much less nodes and complexity.
Absolutely. It's 1/100th the space, 1/10 the energy, and a lot easier a lot less complex to be able to manage.
Well, hey, I'd like to congratulate you guys. This is really exciting, and we can't wait to see more. The pictures have been on the internet of these racks coming in, and it looks terrific.
Great. Thank you very much for having us.